my name is Kaylin, and this is my star chart presentation. I chose Polaris, also known as the North Star, because of how important it's been throughout history and navigation. Here's the graph I made showing the relationship between temperature and luminosity for different stars. Usually, hotter stars are more luminous, especially on the main sequence, but Polaris is a supergiant, so it doesn't follow the exact pattern. Even though Sirius A is hotter than Polaris, it's much less luminous, because Sirius A is still in the main sequence, while Polaris is much larger and more evolved. Polaris is also more luminous than the Sun, even though their temperatures are fairly close. This shows how a star's type and size affects its luminosity, not just its temperature. This is my HR diagram. It shows the relationship between a star's surface temperature and its luminosity. Most stars, like the Sun and Sirius A, fall along the main sequence, where hotter stars are also more luminous. But Polaris is labeled above the main sequence because it's a yellow supergiant. It's cooler than Sirius A, but still much more luminous because of its huge size and advanced life stage. Polaris's position on the HR diagram shows that it's in a late stage of stellar evolution, no longer fusing hydrogen in its core like main sequence stars. Polaris has about 6 times the mass of the Sun, and is roughly 37 times larger in diameter. Its surface temperature is about 6,000 Kelvin, giving it a yellowish color. Right now, Polaris is a yellow supergiant, which means it's no longer on the main sequence. It's already used up all the hydrogen in its core, and it's now fusing heavier elements like helium into carbon. Eventually, it will expand even more and then collapse, probably ending up as a neutron star. Polaris is only 70 million years old, which is young compared to the Sun, but that's because massive stars burn through their fuel faster. It's located in the constellation Ursa Minor, and it's about 433 light years away from Earth. Polaris is one of the most important stars in human history. It's located almost directly above the North Pole, so it appears fixed in the night sky, while other stars seem to rotate around it. For centuries, sailors and travelers used Polaris to navigate across land and sea, because it always points north. That's why it's called the North Star. Even today, Polaris is used to teach navigation and astronomy, and it's been mentioned in everything from ancient mythology to modern pop culture. Polaris is mostly made up of hydrogen, helium, and some heavier elements like carbon and nitrogen. Earlier in its life, Polaris fused hydrogen into helium in its core, like most main sequence stars. But now that it's a supergiant, it's fusing helium into carbon and possibly other heavier elements. This nuclear fusion is what powers the star and produces the energy that makes it shine. Eventually, it will run out of fuel completely and its core will collapse, most likely forming a neutron star. Thank you so much for watching my star chart presentation. Polaris is a great example of how scientists use data, models, and diagrams to understand stars, how they form, change, and eventually die. But studying things like temperature, luminosity, mass, and composition, we can figure out where a star is in its life cycle and predict what will happen to it next.